Hello guys, my name is Timothy Murewa Joseph. In this video, I'm going to teach you how to use the equations of motion to calculate linear motion. That is any problem that is given as a linear motion. So we have three of these equations which I'm going to show you. But firstly, let me explain these symbols to you. We have letter U, which is initial velocity. So we have final velocity, which is also represented by V. Final velocity, initial velocity is U, time is T, you know that acceleration is A, and displacement is S. So you're going to see these letters in these equations. So let's start with acceleration. Acceleration is given as rates of change of velocity, and this is the equation mathematically. So A equal to V minus U, which is change in velocity, divided by time, and the unit is meter per second square. So in this equation, we derive our first equation for velocity, which is V equal to U plus AT, and the unit is meter per second. How did we do this? So we do this by making V subject of the formula here because it is the one we are looking for. So we have a topic in mathematics called change of subject of formula. So to do this, all you need to do is just to cross multiply, which is very simple. Let me just show you. This is like over 1. So we have A times T, that's why we have 8 here, and then 1 times this value, V minus U, we have it here, and then we isolate V because we are making it subject to the formula, and then we arrive at this V equal to U plus AT, and our unit is meter per second. So this is the first equation, if you want to call it the number one. And then let's move to the next equation. Second equation of motion, displacement equal to area under the line. So let's look at the area under the line from this velocity time graph, which is a uniform acceleration. So the area under the line is this, something like this. So this is the area under the line. And then here we've gotten a triangle, and then we have a rectangle under it, so which looks like a trapezium. So displacement is equal to area under the line, as you can see, and then area under the line is area of the triangle. So what is the area of a triangle? Area of a triangle is given as breadth times height, if you want to say breadth times height. Don't forget it as half times breadth times height. So let me write it clearly here. I think it is clear here. Or let me just take away this and then write it here. Area of a triangle is given as half breadth times height. So if you want to say BH, but we know that the sign in between is multiplication. So and then plus area of a triangle. Area of a triangle, yes, and then area of a rectangle is given as length times breadth, that's LB. So okay, so area of rectangle UT, our length, where's our length? Length, and then we've got the breadth here, which is our T times U. That is the area of the rectangle, T times U. T times U, you can see it here, plus area of a triangle, half times T bracket T times V minus U. That is change in velocity. How do we get this? So don't forget I said that area of a triangle is half times breadth times height, and then this is our breadth and this is our height. So our breadth here, we have the T, if you want to call it length, we have the T here, which represents the breadth of this triangle, and the height is change in velocity. That's why we have this guy here, V minus U. We close it, and then, but you need to remember that V minus U over time is equal to acceleration, or if you want to say V minus U equal to AT. So we substitute that value, this value, with this here, AT. We put it here, 80, and then we're going to have 80 square because of this t. So t times 80, so we have 80 square. So this is how we arrive at this formula. So our displacement is s equal to ut plus half 80 square, and the unit is meter per second. So if you like, you can call this second equation. Of course, this is the second equation. So this is how we derive it. And then let me take you to the third equation. This is the third equation, which is similar to the second one. The derivation is similar to the second one rather. So I have explained how we derive the second linear motion equation. So I'm not going to waste time on this, so we can study it. It's similar, the explanation is similar to the second one, but this is our third equation. You can use this equation to calculate velocity. You can also use to calculate acceleration. You can use to calculate displacement too as well. I want us to consider some practical problems so that you can know how to apply these equations. So here we go. Okay, let's consider some practical examples. So this is our question. The driver of a vehicle traveling at a speed of 30 meters per second on a motorway brakes sharply to a standstill in a distance of 100 meters. Calculate the deceleration of the vehicle. First thing you need to understand here, we are asked to calculate deceleration. Deceleration is a negative acceleration. Negative acceleration. Please take note of this. So this negative acceleration, something like this, which means that your answer is going to be negative. So whatever you get is going to be negative. If you don't get a negative answer, it means something is wrong with your calculation, and then you need to go back to the drawing board and check everything again. So solution. First thing to do is to bring out your parameters. So we have our initial velocity, which is 30 meters per second. Final velocity in this question is 0. Our distance or displacement is 100 meters. And then we're looking for the deceleration, our acceleration. So to find acceleration, we are going to use this equation, this third equation, v squared equal to u squared plus 2as. And why are we using this equation? Why are we not using this equation? Why are we not using this or this? Why? 80 squared. So why are we not using this second equation or the first one? Why are we using the third one? So you need to look at your parameters from the question. We have initial velocity, yes, it is here. We don't have acceleration, we're looking for it, okay. Time is in this equation, but time is not in this question. So we cannot use this equation. We can't use it because there is no time and there is no distance given in this equation. So flag off. Then the second equation, we cannot use this equation again. Although we have distance, we have it here, initial velocity is given, but again, we don't have time. So which means if we are to use this equation, we first of all find time, which is a long process for us. So we look for time and then we go back again to calculate acceleration. Yes, so this is the appropriate equation to use, the third equation, because we have final velocity, which is 0, of course, and then we have initial velocity, which is this, then we have distance in this, and then we're looking for acceleration. We are going to make this a subject of the formula for us to get the value of our acceleration. So I think it is not clear why we are using this. So for you to know the correct equation to use for your calculation, you look at the parameter that you are given in your question, and then you consider the equations. Which one do I need to use first, or which one do I need to just put away? So this is how to know the correct equation to use for your calculation. I hope this is clear. So let's go ahead to use this equation. So here we have our v square, final velocity, which is 0 here. I'm showing everything for clear understanding, equal to initial velocity, which is 30 square plus 2a, that is this, times our distance as distance s, which is 100, and then of course 0 square is 0, equal to 30 square, which is 900, plus 2a times 100, so we have 200a. And then here we just uh, collect like times, as we want to call it. So we bring out this 200a. So when it crosses this, you should still remember this equals sign going to the left hand side. So it becomes minus 200a equal to 900 minus 0. So this comes here minus 0 because this is positive here. So it also crosses this, positive crosses this equal sign, and then it changes to negative. Because this is very simple to understand. And then we have minus 200a equal to 900. So this is 900. We are looking for acceleration, our a here. So a equal to 900 divided by 200 minus 200 rather. And then when you do that calculation, we are going to have minus 4.5 meter per second square. So you must remember to put your unit because it is acceleration, although it is deceleration, so which is a negative acceleration. As I said, that deceleration is a negative acceleration, and you can see that we have a negative sign here, which means it is a deceleration. Therefore, deceleration of the vehicle is minus 4.5 meter per second square. So that is the deceleration. This is clear. So let's move to the next one. Another example. This is another question. No. Here we've got another question. A train traveling at 20 meters per second undergoes a uniform retardation of 2 meters per second square when brakes are applied. Calculate the time taken to come to rest and the distance traveled from the place where the brakes were applied. So in this question, we have two things to calculate. Number one, calculate the time taken to come to rest, and then the distance traveled from the place where the brakes were applied. So, okay, so first thing first, we need to bring out the parameter again from the question. So our initial velocity is 20 meters per second, you can see, and then our acceleration is 2 meters per second square. But in this case, it is a negative acceleration. So another name for a negative acceleration is retardation. So please don't forget. So in some questions, you may see deceleration or retardation. So they all mean negative acceleration. So retardation of minus 2 meter per second square. That is why we see acceleration is minus 2 meter per second square here. Our final velocity is 0. And then the time, we are looking for the time. We're also looking for the distance. So the first one, using v equal to u plus at, that's the first equation. We can use this to calculate our time. So we just substitute our value. Final velocity is 0, 0 here equal to initial velocity, which is 20, plus acceleration, don't forget, is negative. So we have minus 2 times t, which is our time that we're looking for. And then we have 2 here. So, sorry, we have 20 here. Again, this is very simple. Again, do I need to explain this? Okay, let me just show this again. So you collect like times again. So we have, we're going to have, so this value minus 2t crosses this equal sign again. So collect your like times. So it's going to be plus 2t equal to your 20 remains, and then this 0 is coming. So we have minus 0, and then that is why we have 2t equal to 20 here. And then we divide both sides by 2 because we are looking for the value of this guy. And that's why we say 20 divided by 2. And then we have our time as 10 seconds. So the time taken to come to rest is 10 seconds. This is it here. Okay, let's go ahead to calculate the distance traveled from the place where the brakes were applied. Okay, the distance traveled. Oh no, if not finished. So we can use this equation now because we're looking for the distance traveled. The distance traveled, to calculate that, we make use of this equation. S equal to ut plus half at squared because we have our time. So we cannot also use this equation. We can't use this equation here. U square, that's the third equation. So you can use this. So you substitute the value that you have. We have our initial velocity 20, our time is 10 minus, because our acceleration is negative, half times 2 times 80 square, which is then our acceleration is 2, our time is 10, so we have 10 square here, which is our time. So by calculation, 20 times 10 is 200. 10 square here is 100. 2 times 100 is 200 divided by this 2. So we have 100 here. And then 200 minus 100 is 100. So the unit is meter. So the distance traveled is 100 meters. So this is very simple to do. I hope this uh, explanation will help you in your calculation of linear motion. Thank you for taking your time to watch. Goodbye.